Assalamu alaikum. Today we are going to see the topic Legendre's linear equation under higher order linear differential equation. Okay, this is the fourth part of higher order linear differential equation. Topic Today's topic is Legendre's linear equation. Okay, before starting this is my YouTube channel Explore Maths with Abdul Azim sir. Like, share, comment and subscribe to my channel. Now let us begin the topic. See, the question will ask you as write the solution of nth order linear differential equation. So this is the method how to calculate, how to find the solution. Okay, so the method is the nth order Legendre's equation is ax plus b power of n d power of n by dx power of n plus k1 ax plus b power of n minus 1 d power of n minus 1 y by dx power of n minus 1 up to kn y equal to q of x. So mark it as first equation where k1, k2, kn are the constants. Okay. For example, see, this is form of polynomial. So like this 2x plus 5 power whole 2x plus 5 whole square d square y by dx square minus 6 into 2x plus 5 dy by dx plus 8y equal to 6x. See here, this 2x plus 5 and here also 2x plus 5. Okay, so this is Legendre's linear differential equation. Another example, 3x plus 2 whole square d square plus 3 into 3x plus 2 whole square d minus 36y equal to 3x square plus 4x plus 1. See here, 3x plus 2 whole square and this 3x plus 2. Another example, x plus 1 power of cube y double dash plus 3 into x plus y whole square plus x plus y into y is equal to log x plus y. See here, this is x plus y, x plus y, x plus y and also x plus y. So these are the examples of Legendre's linear differential equation. Now see here, please understand the method how to solve. So this quadratic equation, let ax plus b equal to e power of z. So wherever we have ax plus b, we will substitute e power of z. Then before this, solve for x value. So send it b there and divide by a. So x value will be e power of z minus b by a. Now this equation, as we have mentioned, second equation named, applying log on both sides. So log of ax plus b is equal to log of e power of z. So we know that power rule in logarithm, z will come here, log z into log e, and also in logarithm we know that log e value is 1. So z into 1 z. So log of ax plus b value z. Mark it as a. Now see here, from this second equation, ax plus ax plus by b, okay, ax plus b is equal to e, this is nothing, so ax plus b equal to e power of z. Differentiate with respect to x. A as it is, x means dx plus b constant is equal to e power of z dz. So a dx is equal to e power of z dz. So dz, bring dx here, so dz by dx is equal to a by e power of z, a by e power of z, and this e power of az means ax plus b. Mark it as third equation. Now this, now see here, we will write dy by dx value is, see this dy by dx, I will write dy by dx, dy by dx, okay, but dz by dz. So now dz by dx, see here, dz by dx is a by ax plus b into dy by dz. So cross multiply, this will go left side. So ax plus b dy by dx is equal to a into dy by dz. So wherever, so d by dz I will write as d dash or d1. So ax plus b dy by dx is equal to a into d dash of y. Mark it as fourth equation. Likewise, similarly, this is ax plus b. Now ax plus b whole square, squaring on both sides. So ax plus b whole square d square y by dx square, here a square, so this will become d dash into d dash minus 1 into y, or d prime into d prime minus 1. Similarly, ax plus b whole cube means ax plus b whole cube d cube y by dx cube is equal to a power of 3 d prime into d prime minus 1 into d prime minus 2. Remember all these three formulae, it will be useful in problems. So okay, d dash means d dash, okay, but x square is there, so a square d dash into d dash minus 1, or d prime into d prime minus 1, or ax plus b whole cube means a power of 3 d dash minus 1 into d prime minus 2. Substitute all these values in first equation, you will get the solution. Now let us see the problems. See here, the question will ask you as solve 2x plus 5 whole square d square y by dx square minus 6 2x plus 5 dy by dx plus 8y equal to 6x. So given this is our given differential equation. See here, this is y, here it is y and y, and here also y. So take out y outside. So 2x plus y whole square, this will become d square, this become d 8 into y plus 8y equal to 6. Mark it as first equation. Now see, this is 2x plus 5. Okay, so this 2x plus 5, as we know here the method. So let 2x plus 5 is equal to e power of z, and if you solve x value plus 5 send to that side, e power of z minus 5 by 2, this is our x value. Now here taking log on both sides, so log of this, log of this. So left side as it is, z power rule, z will come here, log e. As we know, log e value is 1, z into 1 z. So wherever z is there, log 2x plus 5. Now as I have shown you the procedure of Legendre linear equation, this 2x plus 5 d is equal to 2d dash. Okay, see 2 time, so derivative means 2d dash. Okay, this x value will come here 2d dash. Now squaring on both sides, 2x plus y whole square d square is equal to 2 square 4, d dash can be written as d prime into d prime minus 1. Okay, so this is 2x plus 5 whole square here and 2x plus 5d here. So what we will do, we will substitute this value in first equation. 2x plus 5 whole square d square means 4 d prime into d prime minus 1 minus 6, what is this, 2 d dash plus 8 into y is equal to 6. X, what is x value we have seen, e power of z minus 5 by 2. 2 1s are 2 3s are 3 into e power of z minus 5 right side. Now simplify this, 4 into 4 d prime into d prime, 4 into d prime whole square minus 4 d prime into minus 1 4 d prime minus 6 2s are 12 d dash plus 8 into y equal to this one. See here, 4 4 12 8, but here this will become minus 4 minus 12 minus 16. So if we divide by 4, 4 become 1, 16 become 4, and 8 become 2, and here 3 by 4 will be there. So this is nothing but our non-homogeneous linear differential equation, non-homogeneous. So this is f of d and this is x. So f of dy equal to x. So this is for f of d, and x value is 3 by 4 e power of z minus 5. So general solution will be y is equal to complementary function plus particular integral. Before this we will solve CF. So for complementary function, our f of d, this one, f of d, this one. So auxiliary equation is f of m equal to 0. So wherever d is there, substitute with m. So m square minus 4m plus 2 equal to 0. This equation can be solved using quadratic formula. That is the formula, x is equal to minus b plus or minus root of b square minus 4ac by 2a. So m is equal to minus b, b means minus 4 plus or minus root of minus 4 whole square minus 4 ac 1 into 2 by 2a, 2 into 1. So minus into minus plus 4 plus or minus root 4 square 16 minus 4 2 is 8 by 2 1 is 2. 16 minus 8, 8. 8 can be written as 4 into 2. 4 square root 2 into root 2. So divide by 2, it becomes 2 plus or minus root 2. Since it is in the form of alpha plus or minus root b, that is surds. So alpha equal to 2, beta equal to root 2. Okay. So our the roots are in surds. So alpha equal to 2, beta equal to root 2. So complementary function e power of alpha z c1 cos root bz plus c2 sin root bz. What is alpha? 2. What is beta? 2. What is beta? 2. So this is how, and here see z is there, so z equal to log of 2x plus 5. And as we know, the particular integral method is p of I is equal to x by f of d. So 1 by f of d is this one, x means 3 by 4 e power of z minus 5. So this 3 by 4 constant, which will go outside here, 3 by 4, and this multiply here, e power of z by d dash whole square minus 4d dash plus 2 minus 5 into whole this. But here I am writing e power of 0, since e power of 0 is 1. Now as we know that this is e power of x, so here 1. So put d is equal to 1 for this. So now substitute here, d prime means wherever d dash is there, substitute 1. So e power of z by 1 square minus 4 into 1 plus 2. So 3 by 4 outside as it is, e power of z 1 square 1 minus 4 plus 2. 2 plus 1 3, 3 minus 4 minus 1. So minus will come out minus z. Now for here 5 e power of 0. So wherever d dash is there or d prime, substitute 0. So 5 e power of 0 by 0 square minus 4 into 0 plus 2. So 0 square 0 0 plus 2. So 5 ones are, since e power of 0 is 1, 5 ones are 5 by 2. So here see minus is there, minus is there, take out minus common, so minus 3 by 4 e power of z minus 5 by 2. Okay. So this is our particular integral. Now what is our general solution? Y is equal to complementary function plus in particular integral. Why this one? What is complementary function? This one. Minus plus plus, as it is particular integral is minus, so 3 by 4 e power of z minus 5 by 2, where this z is equal to log of 2x plus 5. Okay. Now let us go for another problem. See here, solve 1 plus 4x whole square d square y by dx square 1 plus 4x dy by dx plus 4y is equal to 8 1 plus 4x whole square. So this is our Legendre's linear differential equation. This is how you can understand which form of the differential equation. Okay. So now this is our given Legendre's linear differential equation. See here, this y and this y take outside. So this is 1 plus x 1 plus x 1 plus 4x whole square, this will become d square, this will become d plus 4y of 8 into this one. So mark it as first equation. Now this 1 plus 4x, let 1 plus 4x is equal to e power of z, solve for value of x, so plus 1 goes to that side, become e power of z minus 1 by 4 x value, wherever we need we will substitute. Now for this, mark it as second equation, taking log on both sides, log of here, log of ez. So power rule, z will come here, log e, and we know log e is 1, 1 into z, z. So wherever z is there, log of 1 plus 4x. And we have seen, as per the procedure, let 1 plus 4x d equal to 4 dash. The coefficient of x is 4, and in this problem 2. So now 4, coefficient of x is 4, so 4 d dash. Mark it as that equation. Squaring on both sides, 1 plus 4x whole square d square means 16, 4 square 16, d dash whole square means d prime into d prime minus 1. Mark it as fourth equation. And wherever d dash is there, it means d by dz. Substitute these values, second, third, fourth, in first equation. This is our problem. This is our problem. 1 plus 4x whole square d square means 16 d prime into d prime minus 1, plus 1 plus 4x into d means 4 d prime, plus 4 out of y equal to 8. 1 plus 4x, as we know 1 plus 4x is e power of z whole square. Now simplify this, 16 d prime into d prime, 16 d prime whole square minus 16 d prime into 1 minus 16 d prime, plus 4 d power of 1, or d prime is there, plus 4 of y equal to 8 e power of z into 2, 2z. Now 16 d prime whole square minus this minus 16 plus 4 minus 12. Okay, plus 4. Now here 4, 12, 16. So we can divide easily by 4. 4 ones are 4, 4 3s are 12, 4 ones are 4. Okay. So after division, this will be here 8. See here 8. 8 by 4, 2. Mark it as fifth equation. This is nothing but our non-homogeneous linear differential equation, where this one is f of dy and this one is x. So this is our f of d value, and x value is this one. Okay. Now general solution, as we know that y is equal to complementary function plus particular integral. First we will solve complementary function. This is our f of d. Auxiliary equation is f of m equal to 0. Wherever d prime is there, substitute m. So this a value is 4, b is minus 3, c is 1. So root formula, m is equal to minus b, b means minus 3, plus or minus root of minus 3 whole square minus 4 into c. C means 1 by 2 into a, 4. Minus into minus plus 3, plus or minus root of minus 3 whole square 9, minus 4 for the 16, 16 on the 16 by 2 for the 8. Root 9 minus 16, root minus 7. Since minus is there, minus root is I means complex roots. So this can be written as 3 by 8 plus or minus root 7 I. Alpha means 3 by 8, beta means root 7. Complex roots. So in complex root, we know alpha is this, beta is this. So what is our complementary function? Cf is equal to e power of alpha z into c1 cos beta z plus c2 sin beta z. Alpha means 3 by 8, beta root 7 by 8, beta 7 by 8, z. So what is our z value? Log of 1 plus 4x. Now particular integral, we know that pi formula is x by f of d. X means e power of 2z, 1 by f of d, this one. Since e power of 2z, so substitute d prime value is 2. So 1. So 2 e power of 2z by 4. D prime means 2 whole square minus 3. D prime means 2 plus 1. So 2 square 4. 4 for the 16 minus 3 2s are 6 plus 1. 16 minus 6 10. 10 plus 1 11. So particular integral is 2 e power of 2z by 11. And our general solution is y is equal to cf plus pi. What is cf? E power of 38 by z, 3z by 8 into c1 cos root 7 by 8z plus c2 sin root 7 by 8z plus 2 into e power of 2z by 11, where z is equal to log 1 plus 4x. Okay, now next question. So here solve x plus 1 whole square d square plus x plus 1 t plus 1 of y equal to 4 cos log x plus 1. So given linear differential equation is this one. Take y common outside, so it become x plus 1 whole as it is. Okay, now wherever x plus 1 is there, put e power of z. Send 1 that side, it become x value is e power of z minus 1. Wherever x is there, we will use. Now for this, mark it as second equation, taking log on both sides. Log of 1 plus x is equal to log of e power of z. Z will come here as per power rule. What will remain? Log e, and log e value is 1. 1 into z, z. So z value is log of 1 plus x. And see here, coefficient of x is 1. So as per the procedure of Legendre linear differential equation, 1 plus x d is equal to d dash. Since coefficient of x is 1, so here is 1 into d prime. Now squaring on both sides, 1 plus x whole square d square is equal to d prime into d prime minus 1, fourth equation. Substitute second, third, fourth in first equation. This is our given problem. 1 plus x whole square d square means d prime into d prime minus 1 plus 1 x plus 1 d means d prime here, plus 1 into y is equal to 4 cos log x plus 1. See here, log x plus 1 value is z. Okay, now simplify d prime into d prime whole square, d prime into minus 1 minus d prime plus d prime plus 1 of y equal to 4 cos z. This plus and this minus value cancel, d prime whole square plus 1 equal to 0. Y equal to 4 cos z. This is nothing but our non-homogeneous linear differential equation. So this is our f of d and this is our x value. X is equal to 4 cos z. So first of all, general solution formula is y is equal to complementary function plus particular integral. And now we will solve first but complementary function. This is our f of d. What is our auxiliary equation? F of m equal to 0. Wherever f d prime is there, substitute m. So m square plus 1 equal to 0. Send plus 1 there, it become minus 1 square. It will come here square root plus or minus. Since square root of minus means minus 1 into 1. Minus root means I. I means complex roots. So alpha equal to 0 and beta equal to 1. So complementary function is e power of alpha z c1 cos beta z plus c2 sin beta z. Alpha means 0 into z, c1 cos 1z plus c2 sin 1z. E power of 0, any number power 0 is 1. So 1 into something something. So c1 cos z plus c2 sin z, where this z is equal to log 1 plus x. This is our complementary function. Now we will go for particular integral. So for particular integral, we know the formula this one. Particular integral to x by f of d. X means 4 cos z. F of d means d prime whole square plus 1. So as the case of, in this case, put d square is equal to minus a square. Here z means coefficient 1. So a value is 1. So minus d square, or the thing d prime whole square is equal to minus a means 1 square. 1 square 1. So d square substitute minus 1. Here 4 cos z, d prime means minus 1 plus 1, minus 1 plus 1 0. So here this case f of d dash whole square is 0. Here the case fail. So what we will do in this condition, we know that 1 by f of d into cos ax, when f of d is equal to 0, then 1 by phi of minus a square x by 2a sin ax. Here a and x. Here x is equal to z and a is equal to coefficient a1. So p of a is equal to x. This 4 outside as it is. X means here z. 2 a means 1. Sin ax a1 z. So 4 by 2 z sin z. Okay. So this 4 by 2, it will be cancelled, 2 ones are, and this 2s are. So 2z sin z. So what is our complement general solution? Y equal to complementary function plus particular integral. Complementary function is this one plus particular integral is 2z sin z, where this z or z is equal to log of 1 plus x. So here the topic conclude, but before concluding this is again I am telling, explore maths with Abdul Azim sir. This is my YouTube channel. Like, share, comment and subscribe to my channel. Okay, that's all.